Okay, so we're going to do 4-1 tonight. Um, and this is where we're getting into linear. So if you think about some things, the most famous linear equation we have is slope-intercept form, right? Y equals mx plus b. And they've got it up here as f of x. Now, always remember f of x is the same as what? Y. Good. Yeah. All right. M's the slope. B is the slope-intercept, right? Slope-intercept is where the line crosses or touches the x-axis. Not x-axis. Y-axis. Yeah, I got to slow down my brain. The y-axis. Um, Listen, they go through this stuff right here, increasing and decreasing. I'm gonna show y'all something. How do you read a graph? Or how do you read a graph? Period. From left to right. If that joker's going uphill, it's increasing. That's a positive slope. If that joker's going downhill, it's decreasing. That's a negative slope. If it's flat line, that's a horizontal line. Okay. So I'm gonna show you something. Slope. Yeah, you sing slope, man? Did I? Well, shoot, I'm gonna show you again. Yeah, I can't get my kids in 8th grade to use it. I gave them. The struggle is real. Okay, so here we go. Oh, shoot. Huh? I love you. No, we'll straighten out their ways. Seriously, we'll straighten out their ways. There's Slope Man. So the eyebrow going down is negative, right? The eyebrow going up is positive. The nose is a vertical line, right? It's undefined. Thank you. Why is it undefined? Oh, hold up. There is. Zero in the denominator, guys. That joker's going up. It's rising, but that baby ain't running, is it? So when you have a zero, you can't have so many parts over whole, right? Or over nothing. And then the horizontal line, guys, is the slope of zero. Good. All right. So wonderful. Now, you got it? Zero. Yeah. Little zeros on the end of the mouth. Yep. Okay. We've done, have we shown slope before? Yeah, because we've done rate of change. Yeah. So we've done that. I'm going to show you a little bit different. Point slope form. How many of y'all have ever used point slope form? Do you know why it was even come about? Its whole purpose. Yeah, it's a math class, so it has to be for math, right? Yeah. What is its whole purpose? Why did they come out with this thing? Nope. To give you an easy formula to take a point and a slope and write the equation. Hence, point slope form. Do you understand? You know, we normally, if you got a point and slope, you normally plug it in the x and the y and the m and solve for the what? B, right? And then go from there. That's the traditional ways that are taught. But I like point slope form. You distribute, combine like terms, boom, you done. I love it. It's great. So we're going to learn it too. All right. Determine whether the equation of the curve can be written as a linear function. Well, what they're wanting you to understand is they're saying the equation of the curve because they're about to give you oodles of different equations, right? So they're wanting to know, can you pick out a linear equation? Well, what are some of the prerequisites for a linear equation? Anybody? Huh? Yeah, a constant rate of change, constant rate of slope, so a constant rate of change. But just looking at an equation, how can you go, yep, that right there is a linear equation? Huh? Because of the y? No. No, not because of fraction. Makes a line when you graph it because this guy's constant rate of change. Yeah, but if you're looking at it and you don't want to do anything other than look at it, now you're hunting down the right path. Come on. The domain is all real numbers. Yes, the domain is all real numbers. But think about this. How many variables do we have up here? Nope. We have how many? 2. What is the powers on those variables? 1. If both your x and y both have a power of 1, you have a linear equation. As long as you don't have a variable in the denominator, you'll be fine. You know, crazy stuff like that. But that's how you can know. That's the requisites there. So, ladies and gentlemen, this is a what? Linear. Thank you. Linear. All right. X and Y have a power of what? 1. Good. Now, what do you know about this? It is quadratic. How do you know it's quadratic? X what? Squared. What's Y's power? 1. Okay. Yeah. For most of the functions that we know, Y have a first power, and then X is the one who's getting manipulated, right? So yeah, this is not a linear function. This baby right here is a quadratic, right? Yeah. All right, what about this one? Yes, no, maybe. I think so. If I cover up my left eye and look squintly through my right, will I see what it do? Well, let's do some manipulations. Y'all ready for this? We don't want it to be in the denominator, right? That would be an inverse, right? So let's do this. Oh, snap. X minus 3 over 5 divided by 5, which is really times 1/5, right? Which is, listen, my brain just does not go there, okay? Y'all know when you divide by a fraction, you got a fraction divided by another fraction. Some of y'all can go, it goes in the denominator, it goes in the numerator. My brain just does not go there. I was out that day when we went over that, and I just have not, it just ain't clicking. But look, you see my little way right here? See, I have a bridge. I know that I know that I know, you know? So I'm good with that. So yeah, is that? Yeah, I mean, because look, guys, and I get like this, I could go like that. Sure am. There you go. That's slope intercept all day what? Long. That's good. That's good math right there. I don't care what you say. That's good. I've had a real good, interesting day. Did you see what I've done here? It is, and I should have changed some more colors. I'm sorry. So I just said it's dividing both sides by 5, right? To get the y by itself. So x minus 3 over 5 divided by 5, which is really times 1/5, right? That's, yeah, by 5. Yeah, that's what I done. Yeah. So, all right. Boom. Determine whether the function is increasing or decreasing. Well, first off, guys, if m is positive, increasing, dead giveaway. M is, that's miss. Huh? Decreasing, right? So let's kind of put it, I know that's y, right? Y equals, look at this. I just moved some things around. What did I get it back into, guys? Slope intercept form. I made f of x be who? Who did I make f of x be? Y, right? Because, listen, our mind's so trained. Right, y equals mx plus b. And then I took that slope, put it to the front. So it's a negative slope. So is it increasing or decreasing? That's exactly right. Good job. It is, ladies and gentlemen, decreasing. There you go. That's my Disney D. I'm hoping that Disney one day buys my handwriting for the D. No, I want them to buy my handwriting for the D. All right. What about this one? How do you know it's increasing? Positive what? Slope. Good job. Yeah, there's your slope right there. M equals positive 1/4, right? Now, how do you know whether you got such things? Look, guys. You see how I wrote that above it? Yep. Okay, questions? Yeah, sure will. Yeah. Mm-hmm. Select all the tables which could represent a linear function. Well, first off, y'all have already told me what it takes to be a linear function. What is it? Constant rate of change. So, guys, look. I'm going to go changing x, changing what? So I'm going to go 5. This is 5, right? This is, oh my. That ain't constant. I can go ahead and tell you that ain't constant. That's probably exponential. But I don't even know if it's that. Yeah, it probably is exponential. 3 point something. Yeah. Sorry. 34 divided by 9. Yeah, 3.78 factor. All right, so these are all what? 5s? So our x's are staying 5s, right? What is that? 25? How much is this? How much is that? Check. I got 25 over 5, right? Which all simplifies down to what? 5, correct? All right, so that one's good. I'm going to change the colors. All right, so we still, again, guys, my x's are changing by how much? On all of these, which is real good because once you do one of them, you know the rest of them follow that same pattern. All right, so 9 to -1 is 10 spots. And then that's how many? Another 10, but it's going down, right? Remember? And then it's going down another time. So that is -10 over 5, -10 over 5, -10 over 5, which is negative what? Now I'm talking real quick, so you got to slow me down because I've been doing this for 3 weeks now. With my 8th graders. And I'm about sloped out. All right. What about this last one? What's that, 10? Positive 10? Huh? Oh, my bejeebies. Yep, it sure does. 10, 20, 10, right? Oh, hold up. 10. So 10 over 5, 20 over 10, and 10 over 5. That's still what, guys? 2, right? What did they throw at you right here? They went up 2. So sometimes this right here won't fall out, right? Let me make that go up and you'll see it. And then let me clean it up. I got to clean this side right here up for you a little bit. So that's 5. 10 to 20 is 10, and then that's 5, right? And then this one is 20, right? So they jumped one, and they can do that. Okay, that's one of the little tricks. So just, I'm taking each change, 10 over 5, 20 over 10, 10 over 5. And they all simplify down to what? 2, right? So therefore, all this one, this one, and that one all are what? Linear. When they say select all, what does that really mean? Normally there's more than one, right? That's the dead giveaway. You have a minimum of at least 2, right? Charles like, no.
last three are.
Yeah, the last three are constant. And see how I got each one of them listed out, guys? See how I listed them out? You got to be aware of that because see, they did. They threw in one, and you're like, no, that ain't the same. Yeah, it is when it's simplified, right? That's the key. That's the one that gets you. All right. Now, find the slope of a line in a graph. Listen, folks, I'm going to go ahead and tell you this. My first point will always be, if it crosses the y-axis at a perfect grid point, mine's going to always be right there on the y-axis, right, wherever the y-intercept is. Now, what I'm trying to do is find the next perfect grid crossing, right? So where's it at? Either up or what? Down. Yeah, it doesn't matter, right? So how many points are necessary in order to find slope? 2. Now I'm going to show you something. This right here is pretty cool. Just count. How far we're going up? How far we're going over? Thank you. So slope is change in y over change in x, which is 1 over 1, which is what? Now, here's the kicker on this. It's a graph. So the last thing that you do is, 1, you make sure your fraction's simplified, and 2, you make sure you have the correct sign on it. It's a positive slope, is it not? So therefore, my final answer should be positive, right? If it's going downhill, then my final answer will be negative. But I'm not thinking about that. I'm just looking at how it's moving, right? And then I'll make it negative. All right. Questions? Now, you can't draw triangles on your computer screen, can you? No. Yeah, if you do it, it won't come off. Don't put the white out on it. It's not, it's not good. Screens just don't like that stuff anymore. But listen, Expo, can you write on that with an Expo marker? Microsoft Surface. Oh, not yours, but if anybody else's, that's fine. Okay. Yeah, mine does too. No, I'm just being facetious, y'all. Seriously. If you find those spots and then count how much is it moving in the Y's and then count how much is it moving with the X's, you can do that. You can put your thumb right there. 1, 2. But listen, you look. Have I went anywhere right now? Okay, so you can't start counting until you take a what? Step. That's the biggest mistake right there. Some people start counting before they take a step. We don't do that. You got to take a step before you count. Okay, so you can do that pretty easy, even if it's on a computer screen. All right. Now, what's the slope of this line? What do you mean there's no slope? Every line has a slope. 0. Why do you say 0? Prove it. It's a horizontal line. Nope, prove it. What's it ask for? No slope or slope? What would you say no slope has? If it was what? Vertical. Because it's undefined, right? It doesn't exist, right?
If it's 0, how is 0 slope when 0 is just
a... All right, let's do fractions. Are we going up anywhere? Are we going up anywhere? Yeah, but when you see this, it'll stick like mud. Right? Now, how far am I moving? It really doesn't matter, does it? I'm going to pick 2. Now, 0 divided by 2 is what? Yeah, see, the real kicker between this and being undefined is we have the top is numerator. That's how many parts you shade of how many? 2. So you got a pizza that's cut in half, right? You got 2 parts. Am I shading any? Nah. Right? So that's why this is 0. Y'all good? All right. Slope man. But you also got to know it here. Right? That's the most important. Slope man can only get you so far. Understanding gets you the rest of the way. It's kind of like drowning you, right? We're not surface level learning. We're taking you down deep in less than 40 seconds. No. Just think about it. Listen. You cannot be thinking about what drive-through you just left or what you going through. You got to be thinking about your thinking. Think about some math. You're a captive audience in that thing. All right. So let's sketch a line with the given features. Y-intercept is 0, -1, but the slope is -5/3, right? So I'm going to give you my crash course on slopes and graphing. If it's positive, you'll go up and to the right. If it's negative, let me change colors, you'll go down and to the right. You will always go right. You go right, you won't be wrong. Positive's up, negative is, guess what? Now, there'll be times in your life where you run off the graph. You understand me? You'll run off that graph. So you need to change both directions. Now watch what I'm about to do. Did you see that? All I'm doing is just going back to it, right? If I'm going up, now I'm going what? If I'm going right, now I'm going what? Yeah, I'm just going right back. U-turn. Puts me right back where I began, right? So, because most people, they're good if they stay on the graph. But if you go off that graph, it wrecks some people. Okay? So, just do the up and over. And then down and, switch both of them. I live in pictures. My life is whole pictures, right? Anyway. All right, let's see this one. What do you think this one is? So I'll go up into the what? Left, right? Ooh, sorry. I'll go up and to the left. Well, because I've already gone down to the right. If I go down to the right and off the graph, guess where I got to go? If I got to go the opposite way. Where? Well, I'm going to, but I'm just saying if you do go off the graph, this is how you change gears, right? Does that make sense? I'm going to show you. We're going to switch gears and go up and down that line, okay? So stay with me. The first thing, how you plot a graph, a line. The first thing, you need two things in order to plot it. You need slope and a starting point. The starting point is the y-intercept. So what's the y-intercept? There you go. Boom. Now, we're going. Listen, folks, that's -5/3. So we're going down and to the what? To the right. So I'm going down 5, right? So 1, 2, 3, 4, 5, and over 3. 1, 2, what? 3. Now, I can't put another point, can I? But if I have to change gears and go back to that original point where I went down and to the right, if I go up and to the left, guess where I get back to? That's right. And if I want to go up another 5, 1, 2, 3, 4, 5, and over 3, hello, right there I am. Do you see what I'm talking about? There's your crash course on plotting. But most of y'all could do this with your eyes closed, right? No. Yeah. Linears are normally your foundational function that you learn. But it may have been a while, and that's okay. All right?
So the way that's written is -5/3.
Yep.
The negative only applies to the...
Yeah, to the numerator. Mm-hmm. Yeah, because remember, this is really changing y over changing x. So I'm going to take my my y, my up and down is where my positive and negative is going to go. Positive's going up, negative's going down, but I'll always run to the right. You go right, you won't go wrong. Unless you got to change direction. And if you do that, it's easy to see if you draw the arrows how to change direction. Because you have a visual indicator that shows you, oh, okay, now I know how to go this way. So, all right. Thank y'all. How many points do you need to make a line? Minimum 2. Minimum of 2, right? Good. Huh? You thought I was going to say 3? You can't do it 1. That's a dot. Oh, no. Oh, okay. It's all right. All right. I picked this one. This is an easy one. And y'all going to say, it's easy. It's easy for you. There. Someone do this. Guys, what is this? Okay. You may or may not realize that it is a vertical line. Okay? Depending upon how much is clicking of it. Because we have thrown everything but the kitchen sink. In 2 more weeks, we'll throw the kitchen sink at you. So, there. No. How many variables do you see? That's exactly right. Anytime you see an equation and it only has 1 variable, then you know it's a special case. Period. Because you're either going to see x equal to some number or a y equal to some number. Now, if you go back to your table mentality, doing a table, this means x always equals what? -1. So if you do a table where x always equals -1 and you start just throwing in y's, then you'll realize that this is what type of line? Vertical, right? So you could do it with that. Now, here's the other mindset. It's 1 variable equal to a number. The variable is the axis that's being crossed. What axis is being crossed? The x. Which one crosses the x-axis 100% of the time? Verticals. Horizontal only does it 1 time, right? It touches. It don't even cross it. It just touches it, right? Lays right on top of it. So the number is where, right? So you got a vertical line on the x-axis at negative what? 1. That's right, brother. Yeah, because you think about it in a tabular format. X is always -1, right? Yeah, boom, there you go. Now, I dashed it because if I'd done a solid line, it'd be Wapajaw. So I can do dashes and make it look at least a little bit linear. What's slope on that? Why? Why is it undefined? Yeah, but you can't. I can tell you stuff, but it's better if I prove it to you. Why is it a vertical line? What's the denominator? Am I moving anyway? Am I moving left or right on this baby? No. So the denominator is a what? 0. Can you cut up parts or shade in parts of nothing? If you can, please come see me. We will make millions. We will make millions. We will restructure the elementary curriculum in math, baby. I mean, we'll spend the rest of our life just crossing the country doing seminars. Okay? So. Yeah. Yeah. So, there. All right. I digress. I'm sorry. Y'all are awesome. All right, so we got to find the x and y intercepts, okay? So, listen. If I find the x-intercept, I'm going to say y is equal to 0. If I want the y-intercept, I will say x equals 0. Guaranteed. But I'm going to show you how to do this mathematically. Then I'm going to show you how to do this with an understanding. Okay? So, bear with me. If I want the x-intercept, we just said the y was what? That's right. So that leaves me with 4x equals 36, ladies and gentlemen. Divide by 4. X-intercept equals 9. Now, that's just not a value. That is an ordered pair, ladies and gentlemen. It's an intercept. It's a point. It's an ordered pair. Now, oh, please go back over there. Thank you. The y-intercept, x is 0. So I'm going to take this. I'm going to say 4 times 0 minus 3y equals 36, right? So this becomes 0 minus 3y equals 36. Divide both sides by -3. the y-intercept equals negative 12. That is really 0, negative 12. Okay? Huh? We did these? Have I already showed y'all this? Okay. So, listen right here. Well, I got to write it big, so because that's too small. I can't tell you what I had for lunch yesterday. Well, I ate it at school, so it's chicken. Sorry. Chicken. All right. I use the cover-up method. If I want the x-intercept, then the y is going to what? So I cover it up. I'm left with 4x equals 36, right? If I want the y-intercept, the x it goes to 0, right? We proved it. So cover it up and see what you got left. That's how them teachers do that trick, right there. Okay, but that's how you can graph also from the standard form. That's your way. Because most people, if you have a standard form like this, ax plus by equals c, they'll make you change it in the slope-intercept form and then graph it, right? But you don't have to. You can graph it per the x and y-intercept because that's 2 points, right? Like that. That's good math. Okay. Are we done? Crap. Okay. Okay. Given the set of information, find a linear equation satisfying the conditions if possible. If not, enter does not exist. Does not exist would be for what? Would it be for vertical? Not for horizontal. Be for, but you could still write an equation, right? Yeah. So I'm not sure why they have a do not exist thing. It's kind of crazy. They do. All right. So what's the first thing I got to do? If I've got to write an equation, find a linear. I've got to find the slope, right? So negative 3, 0, 0, negative 2, right? So I do this. Oh, cuss. I'm going to work this, and then this will be it, and then I'm yours. Okay? We'll stay and talk and cut up and whatnot. Negative 3 to 0 is how much? Nope. 3. Why is it positive 3? Because it's going up the what? Number line. Good. How about 0 down to negative 2? Minus 2, right? So slope is change in y over change in x, which is negative 2 over 3. I got to, 1, make sure that I can simplify my fraction, right? Is it simplified? And then I got to look at my signs. I got a negative divided by a positive, so the overall result is negative what?
So, you stack it up as your x-intercept over your y-intercept. Is there a specific reason?
It doesn't matter. You put we'll get the same thing. But the negative would probably be down on the bottom, and that's okay because a positive divided by a negative is still a negative. You just move it up top. Okay? Good question.
You lost me on the first part on where you got 3.
Uh-huh.
You got negative 3 and 0.
Okay. Now, think about a number line. If I'm at negative 3, 0's to the right,
Okay.
so I'm going up. That's a positive change. I'm going up 3 spots, right?
Okay.
Okay. If I'm at 0 and I got to go down to negative 2, that's exactly right. So I think of it like that to get my positive and negatives. Now you could throw a subtract here and go negative 3 minus 0 would be negative 3. 0 minus negative 2 would be a positive 2. And then you just slide that underneath. And there you go. And then you go negative 2/3. That's fine too. Because you're lining up your y's and you're lining up your x's and you subtract. And that's what the y2 minus y1 over x2 minus x1 is. So that's really what you're doing. And this is changing x, so it comes underneath, right? Does that make sense?
That makes sense.
Yeah, change. It's delta. It's delta.
Y over x.
Yeah, it's y over x. There you go. So that's why the 3 come underneath, right? All right, so, guys, here it is. Point, slope, form. Y minus y1 equals m times x minus x1. So my M is what? Negative 2/3 x. Which point y'all want to pick? No, 0 is a coordinate. Which one of these points do y'all want to pick? -3, 0? Y'all okay with that? Okay, so here's an x and a y, right? So my y is 0, and my x is -3. So when I subtract a negative, it becomes a what? A positive, right? So you got to understand when it's x minus something, it changes the signs, right? Okay. Now, so hey, y minus 0. It's good to use the x-intercept because your y value is 0, so it just gives you this, right? Now let's distribute. That's -2/3 x, and that becomes -2, right? Because that would be -6/3, which is what? 2. Yes.
So I'm assuming it's not always going to give us the y-intercept because you could
Well, it will for this one.
just this. I mean, other times it would.
Yeah. Oh man. Okay, I just saw. Okay.
You didn't have to do point slope.
All right, you're right. I didn't have to do point slope because I already had the y-intercept and I had the slope, and I could have done this, right?
It could just give you just two random points, though, right?
Right.
Okay.
Y'all understand? My brain was hooked up on point slope form that I didn't realize that here's the y-intercept. What do I need to write the equation? Slope and what? Y-intercept. Yeah. Yeah. But listen. What do you mean 0? We're picking, yeah, a point has x and a y. But and I've done that. I took that and put it in the point slope form, right? But if I was thinking about things, thinking, I would have realized that's my y-intercept. Just find the slope and I'm done, right? Correct? Because I need two things, slope and y-intercept. Yeah? All right. So, ladies and gentlemen, this is where we will stop tonight. Okay, guys, it's September 24th. We're finishing up 4.1. We'll get into 4.2, 7.1, and 5.2 if time warrants. Okay. All right, so find the slope of line A parallel and B perpendicular to the line -4x plus y equals -7. So they want the slope for a line that's parallel to this and then one that's perpendicular. Well, first off, what we have to do is we have to turn around and we have to go y equals 4x minus 7. Are y'all okay with where I got y equals 4x minus 7? I took this -4x over to the other side, right? You with me? All right, now, so that means the slope is 4/1. Y'all agree? So if you're going to have lines that are parallel, then slopes are the same. Good. So the slope for the parallel line would be 4, right? And the slope for the perpendicular would be the opposite or negative reciprocal, right? So this is a positive. That would be a negative, and that's 4/1, which switches to 1 over what? That's right, -1/4. Any questions? Yes.
Can you repeat that? You said the perpendicular is the reciprocal.
Yes, negative reciprocal. Sometimes people say opposite. Okay. So if you got one positive, you definitely have to have one negative, right? That's how you get your crisscross. And then it being the reciprocal ensures that it's going to intersect and be 90 degrees. Okay. So it's two-parter right there. All right. So determine whether these lines below are parallel, neither are perpendicular. So first things first. Easiest thing is just to put all of them in what? What would we put all these lines in? Slope-intercept form. Thank you. So I got 4y plus 3x equals 12. So minus 3x All right, so I got y equals negative 3/4 x plus 3 for the top one. We'll have negative 12y equals 9x plus 8. And we'll divide everything by negative 12. That leaves me in y equals, that is negative 3/4 x, and that is negative 2/3. Now, there's your slopes. They are what? They're what? The same, which means that those are parallel. Okay? Any questions on that? So it's just basically manipulating the equations. Okay. All right. Y'all good? Yeah. Okay, so write an equation for the line parallel to negative 5x plus 3 and passing through the point 4, negative 21. All right, guys. I'm going to tell you something. We're going to write this, and we're going to use the equation point slope form, okay? So the slope for this one is negative 5, right? If they're parallel, then this slope is the same as that slope of that line, right? So this one would be negative 5, right? So we have a point and a slope. Y'all agree? So we have y minus y1 equals m times x minus x1. So when you plug these things in, you got to make sure that your coordinates change signs. And the reason why they change signs is this. We have y minus y1 coordinate equals x, m, the slope times x minus the x1 coordinate, right? So when you're minusing something, it changes sign. So y, that's a negative 21, so it's a positive 21. Slope is negative 5, it doesn't change. X, and that's a 4, now it becomes a negative 4. All we're going to do is distribute, bring down the y, plus 21 equals negative 5x plus 20 minus 21. Y equals negative 5x minus 1. So that would be the equation for the line that is parallel to the negative 5x plus 3, but passes through 4, negative 21, right? Point slope. Yeah, because it takes a point and a slope. And that's primarily its only purpose. You don't use it a lot, but it is super easy. I like it better than trying to do this. Negative 21 equals negative 5 times 4 plus b. You know the traditional find the b, right? Now you got to write the equation. Y'all remember this? You got to do that. You got to plug that stuff in. You got to plug x and y in a slope. Why not just plug it into the slope, the point slope formula? And when you're done, guess what? You have the whole equation in slope-intercept form, right? I like that a lot better. And that's its whole purpose. Okay? All right. So this one is, we will write it, that is perpendicular, right? So let's kind of look back here. So M1 is negative 4/1, right? when you're looking at fractions or slope, you need to write them as a fraction if you're going to do something with them, like a parallel or perpendicular. Now, I'm going to call this M2, right? So the relationship between line 1 and line 2 is that they are what? Perpendicular, which means it has to be opposite or negative reciprocal. So if I got a negative here, it'll be a positive over there, right? I got 4/1, which would become 1/4 here. Any questions? All right, now I'm right back in the same thing. Y minus y1 equals m times x minus x1. You automatically get your slope right there, but that would be +1, y minus 4, and then of course, let's just add 4 to both sides. There you go. So y equals 1/4 x plus 5. Any questions on that?
On your second M2, your slope on where you got the
Mm-hmm.
1/4,
Mm-hmm.
that came from,
Knowing that they're perpendicular.
so you took that -4 and just made it positive.
That's right. I know that the relationship between perpendicular slopes are negative reciprocals or opposite reciprocals because the product of them better equal -1. And the only way that is, if I took -4/1 times 1/4, that's -4/4, which is -1. And that's what it has to be in order for it to be perpendicular. That's the theory behind it. That's why if one's positive, the other has to be negative, and then it reciprocal ensures that you'll have the 1/1 when you get done with simplifying.
And when you multiply them together, you have to get
A -1.
a -1.
Yeah, that's the theory behind. That's what proves that these are perpendicular, right? So, but normally if you just have -4/1, you know that that's negative, then the other one better be positive. If it's 4/1, just flip it. Just flip your fraction. That's what a reciprocal does. Just top goes bottom, bottom goes to top. Yeah. Okay. All right, that's it on 4/1, right?